Hello everyone, ladies and gentlemen, thank you very much for joining this webinar with us this morning. We are going to spend 1 hour to discuss the digital technology for petroleum and renewable project. Today, our main speaker are Jean-Charles Guillem from To Be First Consulting and myself, Jean Guillem. Just few information before we start. First, you can ask your question during the webinar directly in the Q&A section. Do not hesitate to ask all the questions that you need. We will take the time at the end of the presentation to answer them. Second topic, if you're interested in the slide we are going to use today, do not hesitate to shoot us an email at guillemjean@tobefirstconsulting.com. You can find the link directly in the conversation of this meeting. We will share with you the slide we have used and we will answer your later question if you have some. And the last part is also that we are going to publish some extract of this webinar directly on our LinkedIn page. So if you're interested to see the videos later on and to rewatch them for any purpose, do not hesitate to go on LinkedIn and follow our page. Last information before we start, we have already announced our next webinar. We will take care of the international standards for digitalization. So if you're interested, do not hesitate to join us. It will take place on the 20th of May. You have also the invitation directly in the conversation. You can download it and follow us for our next adventure. Now I'm going to let Jean-Charles speak. Jean-Charles, you are going to start this conversation. Of course, the floor is yours.
Thank you, Jean, for this introduction, and thank you for everyone online to join this third webinar. You understand that we are taking this rhythm to have one session per month after the success of the first two sessions, and we intend to continue in the same way as much as people will be pleased to join them. So today we'll talk about digital technology for petroleum and renewable project. That's a topic which we have chosen, and as mentioned Jean just previously, you can take notice for the next webinar on May the 20th, same time as today, but focusing on international standard for digitization, because it's a topic obviously on which we receive a lot of demand, and so we'll be pleased to address these points on the next webinar in May. So you can start to register from tomorrow on that. For today, the agenda we propose you is a short introduction as usual to remind you the rules of the database projects Smart Explorer, out of which we extract the data and which help us to analyze the market. Of course, we'll question why digitalization apply for petroleum and renewable project. What are the challenges? What are the main technologies and use case we can collect now? What is impact on actors of the supply chain, and how to address the threats and opportunities to go for such a digitalization. And at the end, of course, some bullet points in conclusion that we'll be pleased to share with you from our experience, and we'll have time for question afterwards, as mentioned Jean previously. So just as an introduction to introduce ourselves, I spent most of my career in ABB. I was a group vice president globally, heading the oil and gas and petrochemical market. But in 2012, I decided to leave this nice company to create my own company, To Be First Consulting, and develop digital solution for this market. And I was pleased to have ABB among our first customers afterward to start with. And I am pleased to sit in a number of association or trade organization to share my knowledge and learn myself, of course, to continue to learn every day about this market, and so that's where we are pleased to share this experience with you. You understand that we are a family company. Jean is in charge of the operation in this company, supported, of course, by a team behind us. And Jean has a very similar profile as myself, even if he's still younger. Major difference is that he contributed to create the first digital factory in Air Liquide and operator, which was a great experience before joining us as well in To Be First Consulting. Here, a short list of the paper we are publishing since 2014, so you understand that we are not new in a digital world. That's something we started from day one. And here's those different papers we have published here are addressing, of course, basic information about digital or Industry 4.0. It addresses all the standards, the good practices, but it goes also a number of use cases and the roadmap and good practice. So you may find, depending the level of interest and your background, all kind of accessible information from overview to very detailed specific documents. So be pleased to dig into those database. Regarding our application, we have two products fundamentally. One is Project Smart Explorer, which is this database to trace oil and gas industries and renewables project over the world and start to analyze them, and out of which we extract data that we are pleased of ways to share with you. And the other one is this collaborative platform, Industry 4.0 Smart Platform, which precisely has been designed to speed up the digital transition of the companies in protecting the intellectual property of the companies while moving into the extended enterprise. Regarding the database, some reminder regarding the way we manage this database. Some of you are very familiar with it because they use it every day. But for the others, just to remind you that we cover three categories of project: oil and gas, of course, upstream, midstream, onshore and offshore. Petrochemical, meaning refining, petrochem up to fertilizers. We cover the whole world with all these projects, and we also address energy market, also called for electrification, carbon capture, hydrogen, solar, windmill, waste to energy, and water treatment or desalination. So it's a pretty large scope of the industry, and deeply now engaged in this digital transition. Regarding this digital transition, we have focused on, we have defined digital package for this industry, but to define those digital package, we decided to adopt the reference architecture model Industry 4.0, this famous RAMI 4.0 that some of you may be aware of or are also using on their side, because it's rely on international standards. So that's the most reliable way to qualify and quantify digital packages in referring to those standards. So here you have a picture of this architecture. It starts with the first column, the so-called OSI layers, that many of you know already, because OSI is the anagram of ISO, which is a famous architecture used in automation for decades already, and which help to structure the communication in automation system. But it's of course not enough to trace the digital market by itself, because you must have a second dimension, which is the life cycle of the data and the things, where there is this IEC standards which is helping to do this. And then importantly as well is a third dimension, which brings a hierarchy level to connect things, because you have, if you start from the ground floor of the screw and bolts, these screw and bolts to be connected will have to be integrated in an equipment. This equipment will be integrated in a machine. This machine will have to be integrated in a production unit. This production unit will be integrated in a plant, and this plant is integrated in a company, in a full enterprise, before being connected to the external world through internet. And this connection is very important, that regardless the system used by the company is following these IEC standards 62264 or 61512, because in using those standards, it makes sure that this enterprise can connect its own object or things or services with another company adopting the same architecture, regardless the system it is using, as long as both systems on both sides are using the same standard and the same architecture. So that's why it's very important that to respect this architecture, to speed up and facilitate the connection of companies together. And that's why we decided to follow this architecture to define those 8 packages, as you see on the right. We start with the data capture, then the connectivity and data formatting to share the data and transfer the data operating system, which is of course necessary to handle the data, to produce the asset digital twin, the process digital twin, but also to deploy the cybersecurity, the augmented operator, or the HSSC, also required, of course, in oil and gas and petrochemical or renewable industry. So that's the way we have qualified and quantified the digital packages and potential business in oil and gas and petrochemical or renewable energy project. Why the digitalization? Typically, there are 3 areas where the digitalization can be deployed and speed up innovation and be a source of innovation. First one is your workflow. That's clear that the area where you work and wherever you can deploy digitalization, it will help operation and so on. So that's something which is well known. The second area is your product or services. Okay, it will help to get a better understanding on the way your product services are used by your customer. It can create new services, and that's a way to create value for yourself, but also for your client directly. And the third area is directly to develop a new business model, new services, just in developing activities based on the data which are stored somewhere in your company that you have never used because you had no tool or no idea to do it. But thanks to digital solution, then you would be able to take a value out of those data that were left sleeping somewhere in your company. So that's typically the 3 areas where digitalization can bring value and change the game for your company. Regarding the digitalization benefit on oil and gas and petrochemical, as you know, there are 2 critical phases in this industry. One is the construction of new projects, and the second one is the operation. So during the construction of new project, typically digitalization will speed up the construction. It will facilitate the design. It will eliminate a number of change orders, which are the source of cost, and it will facilitate pre-commissioning, commissioning, and startup of the facilities. Altogether, the first figure we can collect from the field shows a saving up to 20% on the entire phase from engineering and construction and operation phase. So that's a significant saving. And that's the reason why we observe that today majors allocate 55% of their R&D budget into digital solutions. So that it may be some good reason for that. And once the plant are in operation, there is also opportunities to make a massive benefit. First is to help to, of course, build up the process digital loop, and we'll see it in more detail later on, to reduce the maintenance cost, that's quite famous and well known today, but also to cut the downtime as a consequence, and also to optimize the shutdown or plant operation. So altogether, also the figures we start to collect from field show that it's possible to reach up to 15% OPEX performance improvement. It can be by cost reduction, or it can be by performance improvement due to the development of the digitalization of the facilities. The point to take here is very interesting, is that thanks to the digitalization solution, that you can reduce the cost, operating cost, in the same time as you improve the performance. And that's this combination which creates a very interesting virtual cycle in the deployment of the digital solution. The last figure I wanted to share with you is that a refinery produces 50,000 data here per second, which means that you have to store somewhere like 1 terabyte per day of data to support digitalization. So you understand immediately that it's a challenge to store all those data and then to manage them in a proper way. So the digital challenge, of course, is not an easy game, But the key point, the key message we would like to address regarding the digital challenge is that it's not a technological issue. In fact, our experience today, it was maybe the case in 2014, 2015, where no technology were available and nobody had a clue how to proceed on this. Today is no longer the case. I mean, we are 7 years later, technologies is available or shortly available, but it's a matter of process, building trust and commitment between the key players involved in the digital transition, because you cannot digital your company by yourself. I mean, you need the contribution of the different partners, in the beginning, customers, your suppliers, solution providers, and that's what we call the extended enterprise or connected enterprise. And the connected enterprise is not a small word. It requires some condition. And the good news on that context is the standards. I mean, you see those logo, IEC and ISO. In fact, by chance, all the standards for digitalization, most of them exist already. These standards are international, meaning that you have local committee in every country in the world, about 160 or 170 countries which are working on that and improving those standards to make them more operational and adapted to this context of digitalization. So it makes Industry 4.0 system an open system based on international standards, and that's the reason, of course, why Industry 4.0 has been adopted by many countries, including USA, including China, far beyond European countries. And that is this ecosystem of standards which help to facilitate the system interoperability or cyber security, precisely because the solution and requirement, both sides, can match because they are based on those international standards. Regarding the process digital loop, that's often a question we have. What's the interest in oil and gas or petrochemical or even renewables project to build up this digital twin? So you have on the left representation of the existing process control system, where you have a real asset on which you have instrumentation and DCS or safety system or SCADA, whatever you rename it, capturing information and reporting those information to the operator. So when we have this system, why should we have a digital loop on, as we see it described on the right side of the slide? The first reason is response time. Because the conventional loop, the existing loop of the process control system has response time usually in a minute or more likely in hours, sometime even in days. While the digital loop will have response time, which may be in minutes or in seconds, but not in hours. That's something which is much faster in terms of response time. That's the first reason. The second reason is about the root cause analysis. When the system in a conventional way report something going wrong, then the operator has to investigate what is going wrong and why the system is not going in operating condition acceptable, or if there is any risk. That's where things get complicated. And then he has to proceed to investigation. While with the digital loop, the digital loop will indicate immediately where the problem is coming from. Is it a valve? Is it a pump? Is it a pipe? Is it a seal? Is it a motor? Whatever it is, then the root cause will be immediately identified and reported to the operator, so he can evaluate the risk and the remediation, the remedy he can make out of this issue. So that's the second reason. So to do that, of course, this digital loop will start with the data capture from the equipment. So here, the game is to capture the maximum data from the equipment. It can be the pump, the valve, the electrical motors, the switch gears, the transformers, the pipes, the receivers, the tank, etc., and so on. And from this data capture, then the system will generate typically two types of data. The so-called passive data. Those passive data are the data related to the equipment themselves that will help to build up the component digital twin or the equipment digital twin or the machine digital twin. That's the role of the passive data. But of course, through those equipment, it's also possible to capture data related to the process itself, related to the gas, the fluids, were passing by the pump, valve, and all the equipment installed in the plant. And that's what we call active data. And these active data are very interesting because this active data will help to build up the process digital twin and the complete plant digital twin. And that all those information together that will report meaningful information for the operator to help to make the right decision and to correct the operating condition in order to work safe and plan next intervention to fix the issue whenever it is possible or needed. How to implement this digitalization process? In fact, there are two approaches. One is a top-down, another one is a bottom-up. The top-down approach is, in fact, dedicated to the end users. Okay, the operator who decide to digitalize one specific part of plant or a full plant, and it will proceed top-down. The bottom-up approach may also be initiated by an operator, an end user, but it will also be possible to be initiated by the solution provider, providing solution to digitalize some components, some pumps, some valves, some motors, some transformers, whatever it is, and to proceed bottom-up. The interest of this bottom-up approach, which may be combined with the top-down approach, of course, is to provide a quick win. It costs minimum, it presents small risk, it has a high pedagogical value for operators, it's easy to implement, it's what we call the agile approach, and so that speed up the digitalization process in facilities. And so it's very important to be aware of the two approaches, not to oppose them, but to combine them in a smart way at the local field, taking advantage of both solutions. Regarding the technologies and use case to be used in this approach, in fact, there are two concepts to have in mind with unlimited value, which may be created from those two concepts. The first one. Okay.
Here we are arriving at the half of our webinar, so you are more welcome to ask your question directly in the Q&A question, and from there I will take the lead on the discussion. So let me just share my screen so we know we are there. It should be coming normally. Yes, normally you can see me. That's the good news. So here in this part, we are going to address, let's say, the digital transition and the digital technology really from the technological point of view. So the first two important information to have in mind are, of course, two concepts which are behind this digital transition. The first one and first concept to have in mind is the digital twin. If we give a rough definition, the digital twin is a virtual representation of a physical object, process, or service. And the idea behind is really to aggregate information through data all along the life cycle of the project to build around the physical twin, to visualize this information, to model it, to process it, to summarize, and to use those information. The second concept, which is enabling the digital transition, are of course the technology behind big data. You have often heard that big data and let's say data is the new oil. Of course, it's like oil, more or less. You need to extract the value from your data to build information, to build service, and to build value. So those are really the two main concepts behind the digital transition we're having in the energy business, not only for petroleum, but also for renewable. Digital twin, big data, and you will see we'll present the technology and the use cases, and it's really coming from there. If we are looking at the technology supporting digitalization, here we listed 8 technologies that we consider are the most hot topic in our industry. Of course, we would quote way more technology behind it. The idea here is really to focus on the main aspect, the main one you have to understand to be able to master this transition. The first line is, of course, augmented and virtual reality. You have all seen those people with the helmet. You have many use cases behind, especially for operators. That's a brand new field for technology. Okay, we are just at the beginning of this, but the augmented operator is really coming from this technology. The second one is, of course, the hot topic and trendy topic of artificial intelligence. Behind it, we could also put machine learning and all the algorithm work. The idea with artificial intelligence is to go through data, learn pattern, and of course take decision from data and from the information we have through our plant. So it's a huge field. It's already really developed, which is creating a lot of value for our plant. If we go beyond, of course, some technology which are enabler of those technology is the cloud and edge computing. Here, those technology just serve for us for machine to calculate and make the calculation. Without it, it would be just impossible to make able to just gather this volume of data. Jean-Charles was talking about 1 terabyte a day for a plant. You can imagine how much you need to compute to process those information. Then it's a little bit linked, it's a big data infrastructure. With those volume of information, let's say 20 years before, we didn't have the capacities and the infrastructure to store those information, to process them. So of course, big data infrastructure is evolving, bringing not only the solution, but also, let's say, the background to support this innovation. And more we see oil and gas operators just buying data centers like Google or Amazon just to be able to store the information because they know that they need to capitalize on this gold mine. Another set of technology is the Internet of Things. Of course, we are in the energy business, could be petroleum or renewable. We are asset operators. And if we need to make this digital transition, we need to connect our object to Internet, and Internet of Things is the way to do that. Going more into the connectivity and the data capture, we can talk, of course, about satellite and radar scanning. It's really a trend that emerged 5 years ago, where today we can use satellite and radar scanning to operate a plant, to check for leak and stuff like that. So it's really a brand new, let's say, on the side technology, which is not directly to implement our plant, but can be used punctually to help us make our operation better. 3D printing, really important, especially for maintenance. I mean, you don't manage spare parts in the same way if you can print them. So of course, that's a hot topic for all the digitalization transition and for operators. And the last part is the 4G and 5G connectivity. If we need to capture data, we need the connectivity to be able to transport those data. That was something quite hard to do, but the 4G and 5G are making it way easier at the scale of we are talking today about the terabyte. So here are the list of course, technology. We have to make the split between technologies on one side and solution. Doesn't mean you have a technology, you have a solution. And what we see that often the good solution we are seeing on the market are a combination of multiple technology, meaning augmented reality with artificial intelligence or others. And more you combine, more complexities, but more value you can create. So it's really interesting to see that it's a crossover through all those expertise to be able to create value for the potential customer. Now, if we want to enlighten a little bit those technologies, the idea is just to give some, let's say, use cases, example of use cases for those packages that Jean-Charles explained at the beginning. So if we consider data capture, today we have many plants who are in operation around the world where we don't have the 3D model for them because they've been built in the last 40 years. And of course, we didn't have, let's say, the capacity to build the 3D digital twin at this time. But today you can come with lasers technology and scan your whole plant and recreate your 3D digital twin just by capturing those information. And from then you can start to capitalize on your information. If we look at the connectivity and data formatting package, one use case is, of course, the remote operating. Of course, it came a little bit more trendy with all the COVID, let's say, impeachment to travel. But of course, if you don't have, and if you are not able to capture data, pass it to a remote center, and then bring back some orders and command to operate your plant, there is no way you can do it. And thanks to the connectivity new evolution, today you can remote in real time your plant from a distance without any problem. So that's really something we are seeing and will develop in the future, because of course having a lot of team around the world to operate a plant costs a lot of money. The third layer is the data operating system. For those who are not familiar with the operating systems, that's a little bit, let's say, the software like Windows on your computer that operate all the others. Today, the use case behind, and which is, let's say, the more general, is of course the autonomous process pilot. It's a little bit like on the plane, when we all know that the pilot is not piloting the plane all the way through the flight. Sometimes it's just using the autopilot to do it for him, and you have an artificial intelligence who does it even sometimes better than the human. Here, the idea is a little bit the same. If you don't have this data operating system, you can't have this autonomous plant, and the idea is to have your plant just to work on their own and to be able to, let's say, securely scenarize and manage the production. Sometimes even better than human. Now looking at the asset, digital twin, of course, the most well-known, let's say, topic and use case is the predictive maintenance. The idea is to learn, let's say, a pattern of behavior from assets, let's say a pump or a van. And as soon as you detect a change in this behavior, you know that something is going at least wrong, or it's not an usual operation. And there you can detect really at early sign of failure. The idea is not to detect when, for example, rotating equipment is breaking, but just to have this early sign of a crack in the bearing, for example, and there you can do it through predictive maintenance. And of course, the cost of the maintenance is way lower, and you don't have to shut down your whole plant to do it. Going into the process, so a little bit the higher, let's say, vision of your plant, above the asset. Let's say one of the most interesting use case to make saving is the plant operating optimization. If we take, for example, a refinery, you may have different configuration that bring you to the same amount of production. Okay, you need to produce this amount of barrel of oil, for example. You may have different configuration to do it. And here the idea is to train an algorithm to learn from those configuration possible and just to find the one which is optimized, meaning that it will cost you less energy to produce the same amount and same volume. And here you can make a lot of savings, sometimes up to 5% on your operational cost. Then we have the three topics on the right, which are not directly linked to the production, but which are quite interesting as well. The first one, and which is a main topic, of course, in digitalization, is the cybersecurity. If you don't achieve the cybersecurity, there is no way you can do a digital transition efficiently. Of course, the installation safety is a topic. I mean, we had an example recently of a hack of a refinery, and you can understand the consequences if you are not being able to operate your plant anymore, but someone with, let's say, bad intention can do it from a remote place. Okay, it can really jeopardize your safety. So you need to have this cybersecurity implanted to be sure that you are creating value and you're not creating danger. Now talking about people, the augmented operator, we're talking about the virtual reality and augmented reality. Here, one of the most interesting use case today is the maintenance training, meaning you can take your people on spot, put them an helmet of virtual reality and train them over the maintenance operation, maintenance routine. So you know when they are going to actually realize it and execute their maintenance operation, you can be sure that they have been trained, they are used to do it, and so you can save time in your process. You can ensure that they are doing it in the right way and you are not breaking or losing time. And the last topic, which is also quite interesting, the health, safety, security, and environment. And here, based on the technology of radar or satellite, today companies are able to detect oil and gas leak offshore or into pipeline, and that's a way to monitor CO2 emission, which is also quite interesting. Going behind all those, let's say, technological questions, one important question for you is to wonder what is the impact on my side about this digital transition? What can I do about digital technology? As Jean-Charles was saying and stating in the first part, you have understood that nobody can arrive on the ground, not even big companies, and say, okay, I've got all the solution. It happened that the transition is the digital transition is a team sport, if I may say, and you cannot play alone because some people are gathering data, some people have the equipment, some people have the solution, some people have the connectivity. And you can understand that to be able to build all these digital twin, to make all this big data work, you need to have an interoperability between all those solutions, between all those equipment and all those information and all those format of data. So the first impact and the main impact to have in mind about this digital transition is to understand that you cannot do it alone. Okay, I cannot stress this enough, but the digital transition is a team sport and you need to partner with people below you and above you in the value chain to be able to propose solutions and packages to offer on the supply chain and to your end customer. Now, if we look what is the screening behind this, Jean-Charles was already talking about it, but the concept behind this, as you cannot do it alone, is to partner with people and build what we call the extended enterprise, meaning that you are going to work with people next to you on the value chain to be able to aggregate all your know-how, all your expertise, the people from the equipment with the people from the instrumentation and the solution to be able to really create value and make a package offer for that. Of course, the digital turn, like every, let's say, turn we can take, offer opportunities and threats. Here we try to give you just a quick look above it. The first opportunity is of course to turn your market captive on your data. Meaning, if today you are selling an equipment, okay, a pump, for example, it goes and then you don't hear about it anymore. Today or tomorrow, sorry, if you sell your pump, but you also sell the service above your pump and how to collect information, data format, and let's say predictive maintenance solution. Here you are going to capitalize on your information, on your data, and of course, as the operator will have capitalized on your data as well, and the same data, of course, it will be captive to your solution because you will host all this information and all this created value. The second opportunity is also to build additional expertise. Today you have an expertise which can be mechanical, instrumentation, electrical. Today, if you build up this additional brick of digital expertise above your service or your product, here you will create a brand new service, for example, or a process, and it will help to grow and evolve the relationship you have with your end customer. Some people who may not have access, for example, to operators and end users today may, by the means of this digital transition, have access with them tomorrow because they are bringing in additional services. The third point is also as an opportunity to activate the collective intelligence. What does it mean? It means that as to make this digital transition, you are going to have to speak with the guy above you and below you in the value chain. It means that you are going to get closer together and you will be able to fill the space you may have in usual project because you will be closer, because you will have package offers. And here, this is the best way to innovate and differentiate from competition because you will have package offers, you will go hunt business together and you will be stronger together. So that's, you have really to see it as an opportunity because you will be stronger together. And the last part is also that this digital transition by these new services, this added value, will create new business model with more added value. If we take the example of all the airline company, and if we look at the motors, Rolls-Royce, and Safran today, which are the two, let's say, biggest provider of motors for airplane around the world, they don't sell motors directly. Their business model is to sell hours of motors operation. So it's a complete service. It's not an equipment, let's say, business anymore. It's full service, and it's a new business model which for them brings more added value because they are the expert of their asset. They want to be the one to maintain it, of course, and they want to be the one to learn from it, of course, from operation to build the new generation. So I'm not sure if that's a business model that will come in oil and gas, but that's something at least to have in mind. Then, of course, we have the opportunity, the threats. Of course, if you don't take the digital transition, let's say, curve, you are in danger. I have to say it. The first threat is, of course, to get evicted from market requests. We are starting to see it, but today, in many projects, datasheet for equipment not only requires technical specification, meaning your pump need to flow this amount of cubic meters, blah, blah, blah. You also have, and you start to have some digital line, meaning that, okay, your pump need to be able to send this type of data over its operating mode, and you need to send it in this format. If you are not able to answer on those digital line, you'll be kicked out of the project, because tomorrow, and operators know it, they will have and they will need this data capture capacity to be able to create value from their asset. And they are not going to buy equipment tomorrow which are going to prevent them to build value from their operation. So you will get kicked out of those projects. Of course, there will be 1-2 projects, but the threat on the longer time is to become obsolete. Just as simple as you just miss the train of the 4th industrial revolution and your technology is become obsolete. As simple as that. Because tomorrow, the value will not be, let's say, only in your equipment and the quality of your equipment, but it will be also on the way your equipment can create value from data and digital technology. And even if you are not the best, for example, pump manufacturers, if you have the best digital service behind and the best, let's say, added value on your product, you will be the one winning project. The third threat is also not to find the right partners. As you can understand, digitization is happening right now. You need to partner with other people of the supply chain to make it happen. And of course, the first conglomerate to be built will be the one taking all the game. So if you wait 2-3 more years, maybe you will not find the right partners because your partners will be in other joint ventures, in other projects, and they will not be interested in partnering with you. So that's also something to understand that as you are not doing it alone, you have to take the start with the first comer, because the first comer take it all. At the last threat, and that's something which might be a more long-term perspective, is that if the industry and in our industry we don't evaluate, let's say, fast enough toward digitization, someone will do it for us. Meaning that we will have newcomers like, I don't know, maybe Elon Musk from Tesla, and it will bring disruptive innovation on the market. And we have to be the one to disrupt ourselves using those technology, because we are the one today with the know-how. We just need to build this extra expertise on digitalization. So here, talking and changing from the subject of impact, of course, the idea is to go more on the business side and business opportunities. We are going to talk figures, but here just a first, let's say, recap to have it in mind. Today, through our tool Project Smart Explorer, we evaluate 8 packages. Those package is what we call demand side, meaning if we talk to end users or engineering company, for each digital solution service that they are going to be asked for, they want to be able to map it on their environment. And that's the framework they are using. Either your solution is data capture, connectivity, data operating system, asset digital twin, process digital twin. It's about cyber security, about augmented operator, about health, safety, security, and environment. Okay, so yourself, if you are working on those new solutions and you want to bring it on the market, you have to be able to say, okay, that's where I am in the list, and that's the market I'm targeting. Even if you don't cover, for example, all the data capture business, at least you have to be able to be, okay, that's what I'm addressing you for. That's, let's say, the use case I want to fulfill for you. So in our tool, we are really evaluating those 8 packages, meaning what are, let's say, the costs to solve all those issues in a way. And you have to understand that digital packages are a little bit different from what we can compare like mechanical or instrumentation packages. Meaning that for 40 years, we didn't have those digital solutions and plants were already running. Meaning for an end user on engineering, when it comes to build a new plant today, you have to buy all your mechanical equipment, you have to buy all your instrumentation, because your project cannot run without it. With the digital component, it's a little bit different, because the plant could be running without it. It's just that the plant will create less value if you don't have it. So the game for people who are trying to sell digital solution and digital project on the market is to convince the engineering companies and the end users of the interest and the benefit of their solution. So to do it, we often know how much we are going to save using a solution, but we don't know how much it's going to cost. And that's why we have created those packages to say, okay, that's how much you can expect from the cost side, and then that's your game to provide the figures about the saving you can provide. At the opposite, those packages, digital packages, even if they are not mandatory for a project, they are the one who is the highest rewarding today in terms of financing, because they are the one which are at the top of the expertise. As simple as that. It's hard to have this knowledge to build this solution, especially if you are in the mechanical or in instrumentation business. So of course, if you have an offer to go digital, that's where you will make a difference, and that's where you will make the biggest added value on your product. That's also the field where we have the best potential for growth. I mean, we have seen this package of digital from last year to this year just double, and that's a trend we can expect from the following years as well. Going into figures, I exported some figures from our tool, product Smart Explorer, so it might be a bit small, but I'll explain the figures, and if you're interested in a slide again, do not hesitate to ask them to me. I will share with you the slide set we have used today. So here you have, let's say, the split according to, in blue, the oil and gas opportunity for digital packages. In red, you have the petrochem, and in green, you have the, let's say, renewable and decarbonization project. So what you can see really from this graph is that today around 90% of the opportunities in the energy business is really into the petroleum business. Why is so? It's quite simple to understand. In fact, you need digitalization to bring transparency to complex process. And in fact, if we compare, for example, an onshore windmill farm with a refinery, you can understand that the complexity of the project is really into the refinery and not so much into the windmill project. So the refinery would require way more digital technology to be able to operate and to be able to create value than you would need to implement into a windmill project. So that's why if we are talking digital today, even if already the petrol market is bigger in terms of project than the renewable market, we see that the digital technology are more implemented and bring more interest and bring more value into the petroleum industry, because that's where the savings are also the biggest. If we look at the total market for digital technology, today we evaluate at $8.6 billion the volume of packages and solutions you can sell through our framework of 8 lines. If we look at the region now, it's quite interesting as well to see it's quite balanced. You have in a range 30% of the market, which is Asia Pacific. You have 14%, which is Africa. 19% which is North America, meaning Mexico, US, and Canada. You have here 24% which is Middle East, and you have only 8% which is in Europe. Meaning that even if, as we may see in the news, let's say the hottest topic and the hottest publication are made in Europe or in US, you will see that this market is really global. It's quite well distributed around all the countries, and there is not one. Today, we see companies doing digitalization all over the world, and you have to be in some places to be able, and in all places, sorry, to be able to make business, let's say, with the right players, because. What is quite tricky today in this digital transition, because as we were seeing, many opportunities already, many solutions already exist. Really, the tricky part is to implement the solution, and to do it, you need to find the right end users and the right engineering. And that's the last slide and the last graph we have here. We plan the digital packages per type of operators. We have in blue the international company, in red we have the nationally owned company, and in green the independent. If we look at this graph, what is rather interesting is to see that even if you are well actively in making a lot of projects, which is the case of the independent, you might be less active into the digitalization process. And that's something that you may have a feeling about, but our figures are also enlightening that, is that today the leaders, you need to convince to push your solution are the leaders of the international companies, the majors, and are also the leaders of the national oil company. In fact, over the 300 companies we are following around the world, of course, the maturity for those topics are quite, let's say, different. And let's say the IOCs and some big NOCs like Equinor, Saudi Aramco, or ANOC are really the leaders to implement your technology. So that might be the right for you customer to address, to push your solution, or at least to bring their solution on the table to see if you have an interest in developing that in partnership with them. That's something we can discuss in more details, and for people who have the subscription to Project Smart Explorer, you can dig in all the details to have all the detail about it. As time is flying, it's time to go to the conclusion, and here I'm going to recap a little bit the main point of this presentation today. The first one, and the first thing to really have in mind, that the digitalization is no longer a technological issue. All the technology are more or less available. We just need to implement them in the right way to make them efficient on the market. To do it, you have the framework called Industry 4.0, which offer you an architecture based on international standard to make things happen. I invite you to come to our next webinar to have more details about this. Of course, international standards under this framework Industry 4.0 exists, and you can write specification, or they have been written specification to develop interoperable solution. And interoperability is, let's say, just the door opener to go into digital. If your solution is not interoperable, there is no way it will be implemented by end user. Then the idea is to use passive data and active data to feed the digital twin and create service for all parties, not only for the end user by running his asset, but also for you to learn about your asset and about your service and develop additional services. One thing to have in mind, and sometimes it's a little bit hard, is that digitalization for digitalization is a nonsense. Meaning you don't make digitalization just for the purpose of technology, just to say, okay, we have the best algorithm, we have the blah, blah, blah. No, digitalization is a way to innovate. It's just a way to cut costs and time while improving performances. If you don't create value by your digitalization, there is no point in doing it, and no end users will follow you in that sense just to make the headline with a new technology, blah, 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 if it doesn't create value for them. Then one point that I was stressing, but I stress it again, is that digitalization passed by the extended enterprise or connected enterprise. Again, you cannot do a digital transition by yourself. It's really hard. You need to partner with people who have other technology brick to make it happen, and you have to talk with people around you, and together you can achieve it. It's not this hard. As soon as you have the right framework, you just have to start, and then it will come. And then the last part is that the multiplication of use case we are seeing today, and every day we are just listing and adding a list to our adding new use cases to our list, just show how fast the market is maturing. End users are pushing to go in this, and of course, if you are not following it, or if you are not the motor of it, you will be excluded. So the question is more, are you ready, and what are you doing about digitalization more than if it will happen or not, because for sure digitalization will happen and you have to be part of it.